Well, hi there. Thanks for watching. This particular video is going to focus on a simple machine known as a pulley. And by now I think you've seen some of my other videos on the simple machines, and they all have something in common, and that is they're used either to reduce the amount of strength that it would take to move something, for example if something's heavy, or to increase the distance or speed with which something moves, or to change the direction that you need to push or pull in order to get something to move. So typically when you use a simple machine, you always get one benefit at the expense of something else. With pulleys, and these are three pictures here of different pulley setups, they're almost 100% of the time used to decrease the amount of strength required to lift something heavy. And they are often also used at the same time to change the direction. So the three examples that I've shown here, they can each do both of those things. Now, the advantage of less strength comes with it a disadvantage in that you're going to need to pull a greater distance in order to get the object to move. So in my classroom, I'll have a pulley set up for you to kind of use and see the advantage and the disadvantage. So the way we build a pulley, we have these movable wheels here. They just spin around and they're held onto, in this case, like the ceiling through some sort of connection. And then we take a cord and we wrap it around there. Or in this case here, we take a cord and we wrap it around, up and around like that. Now this is one cord wrapped around multiple wheels. Okay? So it's not a bunch of different strings. Now we call them strands of the same string, and I'll talk about strands in just a minute. So every time you wrap the cord around one of the pulley wheels, you decrease the amount of force needed to lift the load. And you also increase the amount of distance that you're going to have to pull on the end of the string in order to get the load to move. Okay, the most important skill you need to have, at least for me, related to pulleys, is to be able to figure out the number of strands supporting the load. Okay? The reason we want to do that, the number of strands supporting the load, will determine the factor by which it feels lighter. So if you need 4 times as much strength as what your muscles will provide, then you need to have 4 strands supporting your load. Okay? So in this case here, here's the load. There is only one place where a string is attached to it. Okay? The number of supporting strands in this situation here is just 1. So that's not going to do anything to decrease the amount of force it takes to move this thing. The only thing this will do is to change the direction you need to pull. So even though you're trying to get something to move up, this allows you to stand on the ground. For example, maybe this is you standing on the ground, and you're reaching up like this and you're pulling down. Now in this second example, if you look at the load is actually attached to this pulley wheel, and there are 2 different strands that are lifting that up. So this has a number of supporting strands equal to 2. And let me move this little guy out of the way. In the situation here in the third one, again, we've got the load attached to this pulley wheel, this movable pulley wheel, onto which we've attached 1, 2, 3 different strands. Again, it's the same rope, but 3 different places where it makes contact. One on the right side, one on the left side, and there'd be a little hook right here that we could tie the end of the string on. So that makes 3 supporting strands for that. So that means this particular situation here, you will get 3 times as much moving force as what you apply to the end of the rope. However, the load will only move 1/3 of the distance that you pull the rope. You see, there's the trade-off. So that kind of leads to my example problem here. If you hang 60 newtons of weight on this third pulley and you need to lift it 40 centimeters, how much force will be required and how far will you pull the rope? Okay, so back up to this paragraph. The factor by which it feels lighter is equal to the number of supporting strands. Now, there's a little bit of a qualifier there. This is going to depend on friction. Okay, so if you have a lot of friction in your system, it'll actually feel even more heavy than that. But let's just use this, let's say 100% efficient machine, no friction. So it will feel lighter by a factor of 3. So we would call this the effort force will equal the 60 newtons that we're trying to move divided by the 3 supporting strands. That means we'd have to only pull with 20 newtons. You're still probably a little unfamiliar with the unit we call a newton. In our traditional system here in the United States, we use pounds to measure how strong you have to pull on something or how heavy something is. But in the international system, often called the metric system, we use newtons for that. Okay. All right, sorry, there's a little jump there in the video, I think. Let's talk about the distance that you're going to have to pull. Because remember, with every machine, if we have an advantage in one respect, we're going to have a disadvantage in the other. So it was nice that we could only use 1/3 of the weight for the strength that we needed to move it. However, the distance we're going to have to pull the rope then is going to be more because of that. So we would call this the effort distance that we're finding here. And because the number of supporting strands is 3, remember this is 1, 2, and 3. I had to get a new sheet, which is why those aren't there anymore. That means the distance that the load moves is going to be decreased by a factor of 3 in this case. So if we need to move it 40 centimeters, then the end of the rope that we pull right here is going to have to be 3 times more than that. So this would be 40 centimeters times 3, or 120 centimeters that we're going to have to pull on the string. So we pull 120 centimeters with 20 newtons of force, and then we're able to move this thing, this 60 newton weight, by a distance of 40 centimeters. So there you can kind of hear, when you look at all those numbers, kind of the advantage and the disadvantage all together. In addition to the idea that I can stand on the ground and pull down rather than trying to, climb up on a ladder or something to lift this thing up. It's a very common way to use this pulley system. So you'll have other pulley problems like this, at least in my class, to try to work out, and hopefully this will be a good guide for you how to do that. I think that's going to do it for now. Thanks for watching.